Now we'll switch to switch the computer and then have the last talk by Pietro Monticone, who is at the University of Trento. And Pietro will introduce us to a new Lean project, which is called LeanArchitect.
Okay, so thank you very much. And I mean, this is not actually, I didn't plan to present a talk. This is a sort of last minute decision. You know, being an organizer of the event is kind of non-standard as I get. But I mean, asked by the main author and supervisor of these new Lean library to give a talk in presence, just because it's more, you know, logistically simple and communicatively effective. So I thought I really just responded affirmatively. And this is actually a very different talk. It's not even a demo talk. It's more, I really want to do things as interactively as possible. So to show exactly what is under the hood a little bit. I mean, I will not go in too much detail, but at least to show what it means to coordinate a Lean project and to work inside it. And what are the kind of hurdles that we have at the moment, and some of the inefficiencies and inconveniences that we have, and why I think that a project like a library like the LeanArchitect actually allows us to improve the quality of life of informal and informal project managers of Lean projects. So as you can see on the top right of my slide deck is actually just 6 slides. For the simple reason that, again, I want to really go back and forth through repositories, and it's going to be very kind of unstructured. So if you don't like that, I'm sorry, but I think it's the most effective way to do it. So yeah, so this is kind of the outline. This is all the things that I would like to talk about. I would start with a few preliminaries, just to, you know, thank a few people and showcase what are all the dependencies of this project, because it doesn't come out of the blue. I will like to give you kind of a few reasons why I really try to motivate as much as possible, why it is that we need that, and how is it that I believe maybe not solve, but strongly mitigate some of the trade-offs that we have and in project management. And then I will talk a little bit about the design and implementation of the tool, even if, yeah, just 1 minute or something. And then I will really concentrate and focus on how it actually works and how it makes our life better. And then a few words about the developments. Actually, some of these future developments are actually being conceived and conceptualized in a call with Alex Kontorovich. So I really thank him for that. And I will talk, and then I will leave space, you know, time for discussion and Q&A. And please, of course, you know, feel free to interrupt me when you want. And let's see how it goes. So I will just go here and stop using this thing. Okay, so yeah. So first thing is I just want to say that everything that I will show here is actually being primarily developed by Thomas Zhu at Carnegie Mellon University under the supervision of Sean Welleck and Jeremy Abigad. And all of this, of course, is built on top of Lean Blueprint. And just please don't get me wrong, this is not something that substitutes the current technology, something that enhances and complement the current technology, I believe. The concept, as you've seen before, like, is inspired by Alex Kontorovich PNT Plus prototype, and the design is actually very much inspired by the DocGen. I know that there are developers at the library, so thank you for that. And again, so this is very much work in progress. It's not production ready, but I think it's a kind of showcase and demo ready, presentation ready. And yeah, so user feedback is very welcome in a sense that I would really like to interact with some of the project managers that I will mention, you know, like, you know, of the main project, like Infinity Cosmos by Emily Reel and Remy in Rhino Motion and so forth, because I think that this is a tool that we should actually use and then decide to integrate into the current pipeline that is quite complicated. Okay, so let me just, thanks is just the last slide that you said. So as I told you before, so let me shift to something slightly different. So first of all, oops, sorry. Yeah. So first of all, this is the repo of the new library, and sorry. Sure. Okay. So this is the new library. Again, it's called the architect, just because it's the step before designing the blueprint, obviously. And I really don't want to give it a demo of that, because I want also to test during project work session and so on how readable it is, the documentation. So I want really you to try if you want, and give me feedback. What I just wanted to tell you is that I just picked one of the Italian projects, right? That I thought was suitable to show you how it is that actually under the hood we work in formalization projects that are driven by the blueprint, and show you why some of these things are actually inefficient at the moment. So this is the quadratic integers project. You're probably familiar with. Some of you are contributing to that. That's nice. And typically, this is how things are presented, right? So we have a repo. We have something like we have the lean or formalization, the formal component, and we have a informal component, right? So all of these projects are as this exact same structure, right? So we typically start from a template, right? Then we install the Lean blueprint, which is a Python library. Then through the Lean blueprint, we generate all of these things, like the homepage of the project. We generate the documentation automatically from the code and stuff like that. And the point is that at the moment, these two fundamental components of formalization projects are disjoint. So if you want, let me just click here. Yeah. So if we go inside the repo, then, okay. So let's see if it works. Okay. So when we go inside a repo and take a look at the formal component, that is what you expect, right? So a bunch of Lean files with, some sort of scaffold and so forth. That's what you're probably used to. And in the blueprint, you have this source folder with all these LaTeX file, right? Right. And these two things are actually connected in a way, not enough, but they're connected through the Lean blueprint technology. How? Well, in the following way, in the sense that when you write the tag that you're used to, you just have a few new commands like \lean, just to say that these lemma environment in LaTeX corresponds, or is supposed to correspond, it should correspond to the quadratic integer dot field declaration in the Lean folder, right? The command lean OK that just signals the fact that that's been formalized as a statement. So as a declaration that has been formalized, not proof, but the declaration has been formalized. And you have stuff like, of course, label that you already know, like just to say this is the informal label, right? But now the problem is that you always have to switch back and forth between the formal and the informal, right? And when you look at, I don't know, something like, let's take this one. Okay. Where I've, added a bunch of doc strings with a bit more context. Well, suppose that these Lean declaration actually, is it maybe change name, right? So you think that this is not a good idea, you just decide to change the name, then you have to go back to the tag and change that there. Or suppose that actually, for some reason, you say, oh, there is another important thing, sorry, that I wanted to say in the LaTeX, that is, it usually improves, but also in statements, we use this command called \uses, which is actually not a Lean blueprint command, is something that the Lean blueprint uses. And this uses command that you see here, right? What it's telling is that within this proof, you're supposed to use, when you plan ahead, right? You think that you're going to use this mean poly thing and this field, right? And then if you're really, really careful, you just ref, all these lemma that are actually, so in the LaTeX, you reference them, right? Okay. But this is a lot of work, right? So suppose that then the formal proof doesn't use field, for example, right? Or suppose that it uses something more, right? Is a complete, that is very, it happens almost always, all the time, right? It is absolutely something that we do not want for humans to spend any time going back and forth between LaTeX and Blueprint this way. And I mean, I've worked on some of these formalization projects and maintained some of them, and I still forget to put the lean OK in the right place and stuff like this. All of this should be automated away. Okay. And this is something like, yeah, so these are the basic commands. There are some others, but these are the basic commands that you should know. If you have, for example, some lean project, some paper of yours that you want to formalize, and you want to blueprintize it first in order to make it more amenable to formalization in a planned way. But so one of the main motivation of this new package that I will show you how it actually works in a moment, but the main motivation is automating these boring, kind of annoying and inconvenient sort of error-prone tasks. And I will show you later in some of the applications of Lean Blueprint when we basically run the Lean Blueprint on already existing projects, we found a lot of mistakes, obviously, right? So, and when you've seen many formalization projects where people show dependency graphs, but I mean, almost all of them are wrong, okay? So if you really, I mean, it's obviously the case, but in this way, we have a way that modulo bugs, of course, will produce that automatically without any effort, and they tend to be more accurate. So there is just automation, there is unification in the sense that both the formal and informal managers have work under the same file, as you would see in a moment, right? So I hope you understand kind of the motivation behind it. But there's another important thing that is more human, more kind of UX, more user experience kind of thing, which is, I think it provides a sort of nice incentive scheme that reduce, quote unquote, not to offend anybody, but quote unquote sloppiness, let's say, when you do these sorts of stuff. Because if they are exactly closed, the informal and formal counterparts are really close, right? When you change something in the formal description or in the formal, specification or proof, then it doesn't cost you too much to actually modify the informal in the same thing, right? In the same session, basically working session. And it's highly unlikely that you forget doing this because you're used to use doc strings for code. When you change something in the code, it's kind of natural, right? To go there and change the doc string accordingly, almost natural, right? So this is one point. And another use case, yes, is accuracy, and another is kind of debugging. Because you might say, oh, but my project is already finished. Yeah, this is kind of, I think, a new notion. Like I would like to introduce this notion of blueprint debugging in a way. Because there are a lot of already completed projects, right? With some mistakes in their presentation. These presentations are used, so it's nice to fix them, right? And you can use the LeanArchitect just to say, okay, let's take the finished informal product, convert back to the formal, produce the automated one, and then keep that one as the clean finished product, right? So also just as for archival purposes might be useful. Okay, and as I said, just to finish this motivation thing, so at the moment I talked about motivation for humans, right? But there are also motivations for AI in a sense that, as Alex showed before, in his case was just inline auto-completion, right? Copilot agents and these sorts of stuff. But that is true also for not Copilot agents, like it's true for Aristotle and other models that take entire inputs. So if you have a lighter informal context, it's just easier to parse. You need less resources, and that's better overall. You don't need a huge multi-file context if everything is there, right? And you don't need to think too much about, oh, in which chapter I put exactly that informal declaration that end up being, that formal one, okay? And yes, and also it provides much more accurate context, right? Because they're closer together. So it's not just a matter of resources you use or a matter of the length of the context. It's a matter of the fact that every single informal thing is closer to its own formal counterpart. So they're associated, by design, by construction, right? So this is another important motivation for AI. And we have done some experiments on that, like, and I will show you a bunch of those later. Okay, so let me let's see if let me just show you in a moment what a dependency graph is. Yeah, this is a very nice. I chosen this project because it's kind of self-contained, very clear to understand. this is actually how a dependency graph looks like in general, right? So there is a legend that explains you what it does, but roughly speaking, you have these squares that represents definitions. You have these ellipses that represent statements or proofs, statements and lemmas of all sorts. So it's kind of theorem declarations. And then you have these dashed arrows that, tell you the fact that the statement of this one is used in this other declaration, and the solid arrows that tells you that this statement here is used in the proof of this declaration. Okay, nice. So you know a little bit about the structure of the project, and I will tell you something about in the future development ideas section, how something like this could actually be generalized for huge projects like FLT and in the Carlson project that has this gigantic dependency graph that is completely unreadable. At the first glance, you don't get any insight immediately unless you're, someone special. And we'll talk about that later. So let me just do one bit. I should have here. Sorry. Yeah. So let me tell you first what the kind of use cases you should have in mind. So you have basically 3 macro scenarios that you should have in mind. So either you have an upcoming project and you're designing a new project from scratch. So you should start from either the Lean code base or the LaTeX code base. If you have something like a paper already there, then you want to simply import the LaTeX, blueprintize it, meaning adding those commands that I've told you about before, and then using a command in this library that is called, is this one, I'll show you here, that's called, is at the end here, yeah, it's just LaTeX script run blueprint convert, right? Again, I don't want to run it here for you because I want to do it in a project session, but this is the informal to formal conversion, which is the rarest thing. But the vast majority of the projects obviously are not, are already ongoing, and you want to say, oh, I formalized like 2 or 3 lemmas, and how can I do that? Can I do that simply using this new architect thing? Then yes, you do exactly with the same command. And we have developed a debugging strategy already where we tested on all the projects, basically all the main projects available, and we refined the code in a way that it should be kind of devoid of bugs. And so your new project is highly likely to be just work out of the box just immediately. And the other thing, as I said, is if your project is completed, then you just want to check that everything works. So it just works as a debugger, but it's not much more than that. Let me just show you. Okay, so this is a very simple example that we put in the README, but later I will show you, how this works for complex projects. But this is how it looks like, right? So instead of writing the LaTeX directly, you just decide what in your formal code base is blueprint worthy. So what is that you want to talk about? What is that you want to put in the informal counterpart? And you just tag, just like you tag a simple lemma, you tag a congruent lemma, like Bhavik showed you yesterday. You've tagged any declaration of any sort with the blueprint tag. And then this blueprint tag has a lot of parameters, right? And you can specify the LaTeX label, right? That will be, so that will be converted into a / label something. Then you can specify the statement using these doc strings. And that is a crucial thing, actually, technically, because at the moment, doc strings only use Markdown to do this. And that is what is used in the DocGen library to produce the documentation. But we actually wanted to distinguish between what is a doc string, meaning a declaration level doc string, or a statement level doc string, or a proof level doc string. So you want to have something like the ability to in the Lean file to be able to say, oh, okay, so the statement in pure LaTeX. So here you can use all your fancy commutative diagrams, TIG-CD stuff, right? And that will work, okay? And in typical doc strings, that will not work, obviously. So now you can use the full power of LaTeX, and that is just something you do like as usual. You put your use packages, your preamble, your crazy stuff and macros and so forth, and that will just work, okay? Then, of course, you can refer informally, as usual. But all this stuff about referring formally doesn't make sense. It just automatically inferred by how your proof works. Okay, so if your proof uses either explicitly or implicitly a declaration, that's going to be added automatically to the backslash uses list of arguments, right? That's what you would like, I think. And the nice stuff is also that we've added a new tactic that's called sorry using. That is that basically does the following. Like it says it's the equivalent of saying backslash uses in the informal, but you say, okay, so there is a sorry, so there is no proof here, but I think that this thing is what you should use, right? So in the same file, that's what you want, right? Because you want both the formalizers, so the contributors, the formal manager and the informal manager to be within the same file to say, oh, I don't know anything about Lean, but I know this sorry thing, and I know this sorry use it thing. And I say, I've called this theorem, right, SACSAD, and I know informally that that's what's going to be used, and therefore I just put it there manually. Okay, that is one thing. But the proof docstrings, this is another thing that is new in a sense that you can, if you use any kind of docstring syntax within proofs, that will be converted into the proof environment automatically. Again, with all the LaTeX syntax. But you can do it much more rigorously, like, right? Because if you're writing down a proof and it doesn't really maybe make sense the first plan that you wrote, you just change the docstring of that formal line, and that will be automatically automated. You don't need to think about that, right? So I think it's much more convenient and more precise. You just write better proofs because you're the informal to formal and formal to informal, they inform each other much better, right? They're much more integrated. Okay, so you can either do this thing here, just really using in the scope of the proof, or you can just add more parameters in the tag scope, and say probably I have something here. Yeah, exactly. Say proof and then docstring, right? And uses is very flexible. You can both just add a declaration. You can add the LaTeX label if you prefer, because sometimes it matters, and then you can say the proof uses and so on and so forth. So all of the thing that we were doing and changing in LaTeX, we're now doing it directly in Lean. Yes, this discussion thing, and maybe almost nobody uses this, but I think it might be useful because this is the number of the issue, and in the current formalization pipeline, we typically have, again, so we have the usual blueprint, but then when we assign tasks to each other, we tend to use, if the project is large enough, we tend to use this task system, this GitHub project dashboard, and we assign tasks to each other. And so it might be very useful to say, oh, this declaration here is actually being worked on this issue, right? So if you look at this issue, you have direct link. And sometimes, for example, I found very hard or still frustrating or inconvenient for example, when I was contributing to the Brain Emotion project all the time, taking a look at the what has already been claimed and stuff like that. If you have a number here, if it's filled, I'll immediately know that somebody's working on it, right? Yeah. So all of this just quality of life improvement. There is nothing really more than this, but I think it's important. And let me just show you some of the use cases that I've talked about before. Like this is the code base of the Carlson project, and as you can see, let's see if I found the right one. Yeah, so this is what it looks like in a kind of real project, kind of real world big project, right? So you have something. Unfortunately, here in the GitHub dev environment, there is no Lean syntax, syntax highlighting, unfortunately, but I hope you can follow anyway. So here you have the Lean declaration, right? That is quite complicated. But then above that, you have the exact same statement, doctrine. It's the same statement you have in the informal, and then basically, yeah. So you can fundamentally say, oh, how do you want that to be called in the informal paper? Is it that lemma, proposition, whatever is the formal counterpart? So you have a lot of, the point is this, you just maximize flexibility, you maximize automation, you maximize integration. That's basically the idea. That what you get from these library. And I just wanted to show you a few of the yeah, I say minor mistakes in projects like these big projects that people cannot really review. You cannot review the entire dependency graph. Like, you know, there are some uses that are, there is no way, there is no value maybe in checking all of them. But if you look at that, at this one should be, is it the old one? Let's see. Yeah. So this is the original one, right? And if you go into the dependency, right, it's very big. You probably cannot learn too much from this. But it seems, if you look at this, it seems that everything is being used, right? Meaning that in this graph, all the nodes have out degree at least one, right? But if I look at what the architect produced, that's not the case, right? Look at those three guys. The three guys actually are not used, are not effectively used. I mean, there is no proof that either explicitly or implicitly use this one. Why? Well, because they were added at the beginning, of course, and then, you know, you just you just forgot about those. And I talked with Flores about this, and he said, oh yeah, actually, these are not really used. We believe that were important, but that's not the case. And I think it's important to have that also mathematically, right? So if there is some simplification that happens, you want this to be automated and to know that this is actually simpler than your previous plan. And that is true also for Fermat's last theorem. It's true in the, so for example, we have seen that in the Infinity Cosmos project, for example, the arrows are only in the statements, are only kind of statements arrows, right? So there was no uses in the proofs, right? Maybe it's wanted and you can do that, but it's not, I was maybe originally thought. Yeah. So all these kind of minor mistakes, I think that if you really want to communicate something, it matters. And let me just, because I really ran out of time, right? So, yeah. Okay. So, okay, these are the applications, but let me just talk about some of the future developments that I have in mind. Okay, so let me just think. Oh, one other thing that I've not talked about is just the automation, also the semi-automation, because it's not really trivial to automate this thing. The semi-automation of the MATLib OK. So, for example, in the brand new motion project, there is a lot of things. These are really nice. It's one of my favorite as a blueprint because it's super clean and there is a lot of stuff that is. This is a really MATLib oriented project, so a lot of the stuff is already being upstream and it's constantly being upstream very efficiently. And so you find something like this attribute blueprint stuff that preserves all the informal information in the lean file, right, without giving any error, any kind of usual stuff. So it preserves the name, the original name, right? But it's telling you that this is already MATLib, but you used it as a prerequisite, and so it will be displayed in the dependency graph because it's more consistent, right? Okay, so having said that, just one thing about the future development that I think is important is that, of course, I've not talked about all the GitHub workflows that we use, all the continuous integration, all of that. But this LeanArchitect is very, very easy to integrate. So it's kind of 3 hours of work, something like that. So I think and then it will I think will really speed up the dev flow, the development flow in my view. And also another idea that is the one that I promised at the beginning that I discussed with Alex Kontorovich is that as you've seen before, these dependency graphs are just are super accurate, are really just the lowest level of abstraction, right? And this is highly unlikely that they're going to use it in any way. So you don't take any insight. You don't really see the point if you're not a super expert there, right? And there are a lot of API lemmas that maybe end up in a blueprint, right? So what we thought about was the idea of, and I'm really interested in your feedback about this, the idea of a multi-layer dependency graphs. So you want to have a notion. I have no idea actually how to visualize it. I'm not a designer and so forth, so maybe I have some better ideas. But to implement is not hard. It's not hard to implement in PyGraphviz. So the idea is that you will tag, at least in this framework, right? You just add a parameter called layer or whatever, or importance or saliency, whatever you care about. And then you will have the situation where each individual declaration is a level 2 declaration, is a level 3 declaration, is more and more important. And so the reader can choose which level of abstraction to read your thing, right? So you can say, oh, let's just go at level 3 because I'm not super expert in that. I want to know what the crucial relations I need to, right? I need to parse, right? To understand. And that allows the reader to choose the level of declaration, but the writer, the expert, to convey immediately, right, what the importance level really is. And of course, there are some issues with uses transitivity and so forth, but that's already been taken care of in this package. So because of course, if you have A that depends on B and B depends on C, then if A and C are level 2 and B is level 1, you want A to depend on C, right? Even if it doesn't directly depend on C. But yeah, so I think these are all minor technical details that we can quite easily solve. And so I think that this is the whole thing. And yeah, any questions? Just thank you for your interest. Nice.
Is there, so thank you, Pietro. Is there any question for Pietro?
So if I understand correctly, you can hide declaration that you don't want to be seen in the blueprint. You just don't tag them at blueprint.
Exactly.
Okay. Can I also add dependencies? Because maybe, I mean, I don't want to really to show all the dependency using the proof because maybe some of them are not so important.
Exactly right. Yes.
It's possible. Okay.
Yeah, it's possible. So you can personalize just saying uses, and then you put in the parameter, in the uses parameter, your own declaration, only those that you want. Actually, it's a good idea to put an exclusion.
Yeah. Because
there,
Lean will find a lot of dependency for each proof, and maybe too much. And okay, exactly. To say, okay, I don't want to see this one.
Sure. Okay. It's easy to implement. We can just need to put a minus in. Thank you very much. No, that's a great idea. I want to add into the thing.
Remy and then Philippe.
Other questions? Yeah.
I think it will be a great tool, and I am very impatient to use it. About the blueprint graph, the dependency graph, it would be also very helpful to have not just nodes that are more important than others and stay active, but also some kind of node that at one level represents all the other ones. A thing that I've been doing in my blueprints is that you have some dummy node that says, okay, all the basic properties of that object and all the basic lemmas just link to that one, and I reuse this to have some groups where like that abstract all those very immediate API lemmas.
And so are you talking about something like a multi-edge graph or something like that, where the edges are actually different types of things? So you can have an edge with the metadata with like, is it like uses or something else?
Yeah,
because it's not uses, right? So you will not be,
no,
you will violate the definition of use edge.
What I'm thinking is that, okay, maybe you want a graph with less nodes because you showed the Brownian motion graph a moment ago and it's huge and you can't see anything.
Yeah.
But a way it could be done is that you have a cloud of unimportant API lemmas and they become one meta node in a bigger view.
I see. Also, okay, but the criteria is by file, by module, by.
I don't know.
No, we will discuss it later. That's a great idea, actually. Yeah, it will be great to have more freedom for the user to say either, let's just use the edge, the deductive dependency, or use something like some other criteria for the edge. Or yeah, that's great.
Yeah, thanks.
Okay, thank you very much. Michael.
Okay, so okay, so thanks. I really find it great. I have a follow-up question from Ricardo. So you said you want to maximize automation and flexibility. Well, but they are a little bit antagonists one to the other in a sense, I would say. Because now if I can add my uses by hand, well, then I can introduce mistakes. Because then I'm introducing uses that at the end of the day I'm not using. But since I'm forcing it to, because I can write /uses, and then if I eventually...
Well, yes. So actually, if you at the moment, if you add some parameter in uses by hand, what it will be displayed is actually the union of the automatically inferred ones and the manual ones. Okay, at the moment, that's the safest option. Let's say, yeah. But yes, with the new idea by Ricardo of tagging them by a minus or something, that would be nice. But still, I think that we just need to add another thing that throws an error. If you say that, yeah, we just have to deal with that. I understand your point. Like,
maybe a warning saying, okay,
yeah, a warning.
Are you really sure? Because
but
this is not using it. If you want, I can print the error, but in my opinion, it's,
Yeah,
and then of course the user decide. But at least there's a warning saying,
Yeah, warning is
okay,
great,
you
yeah.
you tagged it, but it's no longer the case or something.
Yeah.
Or
Yeah, it's a great idea. And just to reply to your point of these are in conflict with each other. Yes, that's exactly correct. Because at the beginning I said there is this trade-off, and actually I think there is a kind of a blueprint debate going on, if I'm not mistaken. And by blueprint debate I mean there exists at least one Zulip topic thread on this, and I've witnessed at least one conversation in a workshop or something like that, where people kind of fight over this issue. Yeah, there exists at least one, and about this, it's better to have only one file, or it's better to have multiple files. So, but I think it's at least this tool will not fully resolve, but mitigate this trade-off. There is necessarily a trade-off. Yeah, I agree. Yeah, Michael.
Thank you for your talk. It's certainly thought-provoking and inspiring. So I have, I think, one comment on Remy's question, like how can I get the flexibility of having a meta node? You can do that in the existing blueprint. Just make a lemma with all the basic properties and then tag several lean declarations. I'm just not sure how the new architecture will allow for that. That's actually one concern I have, that it's less flexible, and I'm not sure if that's helpful. Saying my lived experience in the Carlson project, I think there's several differences that are worth pointing out. So one is that there's actually a math team and a formalization team, and the math team wrote the blueprint without knowing, basically without knowing any lean. The formalization team formalized it without being experts in harmonic analysis. And I think that's a feature. So having separate files is actually good here. At least for this case, like having a separation is good and it should be definitely opt-in. The other point being that if I have done a lemma in this conventional blueprint that's perhaps standard length in LaTeX, it might be several hundred lines in Lean, and you don't want that to be a single declaration, but several of them. I don't see how having the LaTeX interspersed with the Lean will actually help readability here. I mean, sure, this is opt-in, and if you find the new structure useful, that's good, use it. But I'm not sure if you're solving a problem, if you're solving problems that, say, the Carlson project has.
Sure. So let me respond to each point. So let me start from the last one because I think it's simpler. So the Carlson project as a blueprint, as you know much better than I do, is a blueprint that is really, really, really peculiar in the sense that it has all definitions and propositions and statements at the beginning, and then there is this proof part, right? So there is a lot of proofs at the end. This is not a standard, but I think that we can integrate that. I mean, we actually already did that. The Carlson project is perfectly compatible with the architect, and if you run the blueprint convert script, it will just work. I understand your point about huge proofs or something like having multi-line proof doc strings, but and that will actually, I understand that will actually kind of clutter also the thing, yeah, but not in the working session. Why? Because the doc strings are foldable, right? So when you work on them, you can just fold this thing in a single line. I understand that in the code base will still have that. Understand? we can definitely improve. I think there might be some ideas to improve that. But I think that the cluttering is not really a development process problem. It's more of, it happens. So it's more of a completed project problem, kind of archival problem. It's not really in depth, but we definitely can discuss that later. I'm really interested in your point of view here. And then yes, from your first point, my answer is that actually I've talked about future developments as if the only way to do this, so like the blueprint, the multi-layer dependency graph was something related to the architect necessarily, but actually would be optimal to do it would be better, strictly better, I think, to do it at the more fundamental level, so at the lean blueprint level, just to make it more flexible. So I totally agree with you on this. It's not something we can do downstream on the architect, but it's better to do it upstream on the blueprint. So we agree completely on this. Yeah. So it's just a future developments idea in general. So for the general ecosystem, it's not like very much related to the architect. Yeah. But thank you very much. And by the way, let's discuss that later also. I really want to annotate everything. So.
Thank you so much, Pietro.